Now on our next problem, notice the 1/3 is outside the absolute value. So it's a vertical dilation. In this case, it's less than 1, so it's a compression. So my graph, my V is going to get wider. By 1/3. Now, if you have a negative on the outside of your function, outside the absolute value, it's going to make it flip over the x-axis. So it's going to become upside down. If you have a negative inside, you're going to flip it across the y-axis. And when you flip it across the y-axis, since it's symmetric, it's going to look the same. Because every point that's to the left is going to be on the right. But we should understand that we did actually do a reflection there. So let's describe what's going on here. Notice my negative is on the outside. Since my negative is on the outside, it's going to flip over the x-axis. And when we flip it over the x-axis, it really just becomes upside down. My V points down. Inside, remember it's backwards. It's a translation, so I'm going to go 3 right and 5 up. Now on the next one, we're going to describe what's happening. Well, notice the negatives on the inside. So first off, I'm going to flip over the y-axis. And like we said, when we flip over the y-axis, my V essentially looks the same. But then I'm going to do a horizontal dilation. In this case, it's a compression. By 1/4. So in other words, it's going to get wider.